And the people living in these buildings are very satisfied with the living conditions, and all of them are very proud to live in the passive house. So, based on the experience of passive house in European countries, we try to find out the feasibility of the passive house in East Asia. This is the image of the residential areas in Seoul. Most of the new constructions are high-rise apartments. And the technical measures are also adopted to improve the performance of the existing building in this renovation. It includes the outside wall insulation and windows and airtight connections, and the minimization of the heat bridges, and the ventilation system with heat recovery, distance heating, active cooling. And from the section and the floor plan of this apartment, you can see the building's envelope was completely enclosed by insulation material. And the facility system in this project is the same as the Vienna project. It is a centralized heat recovery air handling system. This 2 point represents the centralized duct in the pipe shafts, in the pipe shaft in the building. And we use a passive house planning package to calculate the energy consumption in these buildings. This table is the result of the calculation. From the results, we can see if the room temperature was kept at 22 centigrade, the heating energy demand for the south orientation room is 14 kilowatt hour per square meter a year. For the north orientation room, this figure is 19. This figure can say it meets the requirements of passive house, but the primary energy demand is a little bit higher than the passive house standard. It is because the cooling energy consumption in summer. And this is the image of the newly constructed residential area in Beijing. And, most of the residential buildings are high-rise or multi-story apartments. For the residential buildings constructed before 1990 in Beijing, there is no insulation for the exterior wall. Generally, the exterior wall for the residential building is a 37 centimeter brick wall. According to the current design standard of the energy efficient residential buildings in Beijing, there should be at least 5 centimeter insulation adding to this 37 centimeter brick wall. And the building constructed according to the current design standard can reduce nearly 65% of the energy consumption according to the old residential building constructed before 1990. And if we design and construct the residential building according to passive house standard, there should be at least 20 centimeter insulation, and the energy consumption and the environment impact could be further reduced to 1/4 of the current residential buildings. And this illustration shows the different environmental impact and energy consumption for the residential buildings in Beijing in different phases. So if the passive house, if passive house can apply for the housing in Beijing, there will be a huge contribution to the energy and the environment. According to the experience of the project in Zhou, we can find it is possible to realize passive house from the technical point of view in East Asia. But if we transfer this concept to China, there should be still some problems to be solved. The first one is the climate difference. And the second is the culture and the living style. And the third one is the additional cost. For the climate difference, Beijing is located in north part of China. And from this picture, you can see the altitude of Beijing is nearly the same as the altitude of Madrid in Europe. But from the climate data, the climate in Beijing is actually more continental in winter and more subtropical in summer. And that means the winter in Beijing is colder, and the summer in Beijing is hotter than Madrid.
Stay in Holland. You can stay in Holland.
So, according to the climate feature of Beijing, besides the winter strategy for reducing heating energy consumption, the summer strategy for reducing cooling energy consumption is also an important issue to consider. This is the image of the building's facade of the residential building in Beijing. People always use a kind of a split type of air conditioner for cooling. A lot of air conditioners hang on the building's facade. But if we can create a better cross ventilation for the housing unit, we can shorten the period of using the air conditioner. And by this way, we can reduce the cooling energy consumption.